Okay, now I'm going to show you another way of getting to a characteristic equation for the same circuit, the parallel circuit, but doing the derivative. So I start this black circuit here, I start still doing KCL, and I still use the fact that VC is the same as VL and the same as VR, and it's LdI dt. And I go off of this equation here. Instead of continuing to substitute VC with LdI dt, I can do the derivative on both sides. So if I take the derivative of IS, which is a scalar, 286 is going to be way more complicated. This goes to 0. But here, it's going to be C d2 VC dt2 plus dVC dt, but 1 over R multiplied by that, and then DIL dt equals 0. So hopefully this makes sense to you that I'm doing the derivative of this side and this side. And now I'm going to use the fact that VC is, that DIL is VC. So here, actually, I take that back. DIL dt is VC times L, and VC divided by L in this circuit. So I'm going to substitute this here. And other than that, this will stay the same. So C d2 VC dt2 plus 1 over R dVC dt plus 1 over L VC equals 0. So this is a second order equation as a function of voltage instead of current, but I will also divide everybody by C. So divide by C or multiply 1 over C. And now look, I end up with an equation that's d2 VC dt2 plus 1 over RC but it's a homogeneous, or some people say homogeneous. So also a characteristic equation for parallel circuits. So you see that RC, here I wrote CR, but it's RC, LC is here. But instead of equals to the current supply, it's equals to 0. The reason is that this here, for a current supply, if you're looking at the capacitor, the current supply is for t tending to infinity, supplying current through the inductor, but the voltage across the capacitor is 0. So this is turns out to be a source-free circuit from the perspective of the capacitor, because it ends up with 0 volts. But the inductor, no, the IL of infinity ends up being IS. So this here is the forced solution for this, for IS, if we're looking at the currents through the inductor, but voltage across the capacitor is 0. Having said that, this is the only difference. The coefficients for the terms here stay the same, RC and LC. Now we're going to see how to solve this.